In this video we will look into forecast errors, accuracy and the concept of tracking signal, and forecast control charts. Forecast accuracy. Forecast is never completely accurate. Forecast will always deviate from the actual demand. The difference between forecast and the actual demand is the forecast error. A large degree of forecast error may indicate that either the forecasting technique is wrong, or it needs to be adjusted by changing some parameters, for example, the alpha in exponential smoothing forecast. Measures of forecast errors. There are three methods. Number 1 is mean absolute deviation, called MAD. Number 2 is mean absolute percent deviation, called MOPD. Number 3 is cumulative error and average error or bias. In this tutorial video, we will be concentrating on mean absolute deviation. Mean absolute deviation. Mean absolute deviation or MAD is an average of the difference between the forecast and actual demand. MAD is calculated as summation of absolute value of errors divided by N, as shown in the formula. As we understand, absolute value negates the effect of negative values. Mean absolute deviation or MAD. The smaller the value of MAD, the more accurate the forecast is. However, it depends on the magnitude of data which is being evaluated. For example, a MAD value of 4.85 cannot be compared with a MAD value of 485, and conclude that former forecast is good. These MAD values depends to a certain extent on the relative magnitude of the data. So, such comparison is not accurate. However, accuracy of several different forecasting techniques applied on the same data can be compared using MAD. Let us now try to compare the values of mean absolute deviation, or MAD for two forecasting technique applied to same data set. In the table here, with the demand values from May to December, first forecasting values are calculated using exponential smoothing technique, with alpha equal to 2. We then calculate the error values, which is demand minus forecast values. Thus, for the month of May, it is 100 minus 105, that is minus 5. Now, we calculate the absolute value of the error. Since the error value for May month is minus 5, its absolute value is positive 5. Similarly for June, the error value is minus 24, and absolute error value is 24. Finally we sum all the absolute error values. We obtain 90.33. This is divided by number of month, that is 8. To get the mean absolute deviation, we find MAD for exponential smoothing forecast as 11.29. We again use the linear trendline forecasting method to calculate the forecast as shown in the table. The error for May month comes out to 6.67, and the absolute error value as 6.67. For June, the error value is minus 17.55, and the absolute error value is 17.55. We continue this process till the month of December. Then, we sum up all the absolute error values. We get 60.32. This is divided by 8, to get the MAD value. In this case we get 7.54. Thus, we observe here that for the same data set, the MAD values for two forecasting techniques are different. Since the value of MAD for linear trendline forecasting is lower than that of exponential smoothing forecast, we consider linear trendline forecasting method as more suitable for this data set.